So all the titration questions are there in this sheet. A student investigating a redox reaction in which oxidation and reduction take place for potassium iodide and iodide ion in two experiments were carried out. So first, a burette is filled with solution A and in a conical flask, student took 10 cm cube of solution B. So there is solution B in the conical flask and the volume of solution B is 10 cm cube. Student add starch solution here because when we add potassium iodide, it will form iodine molecule, and in the presence of starch, iodine, it will give a blue-black color. But when we add thiosulfate, sodium thiosulfate from the burette, as a result, what will happen? The iodine concentration will start to decrease and the solution will get paler until there is no more iodine, so the solution color will disappear. So this is a burette reading. How much is this? So 16.8 cm cube is a burette reading. We have to use this burette reading and add in a table. Then second experiment is also done. So student did the second experiment, and this time the second experiment student took the same solution A of thiosulfate, but instead of using solution B, the student used solution C, the same amount of solution C as B, which is 10 cm cube, but the difference, the concentration of iodine is different, like potassium iodide is different. When student adds solution A from the burette, as a result, how much solution is added? So how we can identify how much is added? So initial burette reading was 17.1 and the final burette reading is 25.5. So when we take a difference, it will come out as 8.4. So 8.4 cm cube of solution A is needed in experiment 2, whereas 16.8 cm cube of solution A is needed for experiment 1. So it means solution B is having a high concentration because it needs greater amount of A for a complete reaction, whereas solution C is having a low concentration because small quantity of A can completely react with C. So we have to fill up the burette readings. The final burette reading in experiment, it was 16.8 and the difference is also 16.8. Whereas experiment 2, initial reading was 17.1 and the final is 25.5. So difference was 8.4. The question is the reaction of a mixture potassium iodide, sulfuric acid and potassium iodide in the flask produce iodine. Sodium thiosulfate react with iodine. In which experiment was the greatest volume of thiosulfate needed? So because the burette was filled with a thiosulfate, and you can clearly see the difference in the volume in experiment 1 is more than experiment 2. So the answer here is experiment 1. Then compare the volume. How we compare the volume? We just have to take the ratio when we are comparing. So what is the ratio between 16.8 and 8.4? So when we divide both of them by 8.4, so it will be 2:1. So how we write the answer here? We'll mention that the volume used in experiment 1 is twice compared to experiment 2. So experiment 1, it is a twice compared to experiment 2. Suggest an explanation for the difference in volume. Why the volume of thiosulfate used is different? So what is the reason for that? The reason is the solution B and C have different concentration. Or contain different amount of iodine, and which is more concentrated? B is more concentrated because it needs greater amount of sodium thiosulfate for a complete reaction. So if the unknown solution is in a conical flask and you want to identify which unknown solution is having a high concentration, so the one which required a greater amount from the burette, it means that is having a high concentration. But sometimes unknown solution in a burette. So if we use a small quantity of unknown solution for a reaction, it means that is more concentrated from the burette. We'll do more questions. You will have an idea that how a question may differ. Predict the volume of solution A, which would be needed to react completely if experiment 1 was repeated 10 cm cube, 20 cm cube. So when we did experiment 1, uh, solution, because experiment 1 was the reaction between A and B. When we took 10 cm cube of solution B, how much A was needed? 16.8. If we repeat the experiment with 20 cm cube of solution B, then how much A is needed? So it will be X, just cross multiply, so it will be twice. So 16.8 times 2, that will be 33.6. So 33.6 cm cube of solution A is needed. And explanation here, because the volume is twice or volume is double, so we need a greater amount for a complete reaction. Suggest a reason why the starch was added. So what is the purpose of the starch? Starch is used as an indicator to show that all iodine used up, we use this starch. So whenever a chemical reaction involves iodine formation or conversion of iodide ion to iodine molecule or opposite, we use starch as an indicator, because the starch gives a blue-black color in the presence of iodine. Is it clear, this question? Another titration question: a student investigated an aqueous solution of a calcium hydroxide with water. Two experiments were carried out. In experiment 1, by using a measuring cylinder, student adds 25 cm cube of aqueous solution of a calcium hydroxide into a conical flask. Then phenolphthalein is added as an indicator and a burette is filled to 0 mark with hydrochloric acid. So the main reaction that we took sodium hydroxide in a conical flask, calcium hydroxide in a conical flask. And how much calcium hydroxide was used? 25 cm cube. Then the burette is filled with solution M of hydrochloric acid. Like solution M means hydrochloric acid with unknown concentration. That's why they label as M. The solution M was added slowly until the color disappeared. So using the burette diagram, record the volume. So see that how we record the volume, the difference between this experiment and the first experiment. The first experiment, when you check the scale, it was in ascending order, like from bottom it is a small number and top. So we read from bottom to top. And here what happened in this experiment, at the top we have a smaller number and at the bottom we have a large number. So it means that the scale is, when we are going up, it is descending. So what we read, we always read the burette from smaller number to greater number. Like here, when we read how much, what is the reading? A burette reading. So it is 10.1, 2, 3, 4, 5, and 6. So we'll say it is 10.6 cm cube. But in the previous experiment, when we read this, so we read the scale from the bottom. So we read like 16, 17, and then 17.1. And here as well, 25 and 25.5 was there. So it's important that you check how the readings are shown. It's from top to bottom or from bottom to top. Yeah, the air is present, but the thing is that how much liquid is removed from the burette, that we need. It's not like how much liquid is present. The important thing is how much liquid is removed. So when the scale is starting from the bottom, directly we just read the scale and we know how much liquid is being removed. And when the scale is starting from the top, we read amount of air present, and amount of air present shows basically this is amount of air. So how much air is present? It means that is the amount which is removed from the burette. So remember this technique, like whenever a scale is starting from like top number is small and down is big. So we read from top, always from small to big. So here the reading of the burette or the burette reading is 10.6. And then experiment 1 was repeated using solution N of hydrochloric acid, and hydrochloric acid is in a conical flask, is in a burette. So we did this reaction twice. So first we were having solution M of HCl, and then we have solution N of HCl. M and N means like both are HCl, but they have a different concentration. And for the first reaction, phenolphthalein was used as an indicator. We were having a calcium hydroxide. And how much calcium hydroxide was there? 25 cm3. Then the experiment was repeated. Same 25 cm3 of calcium hydroxide. So when we check the first one, like first it was 0, and then when we read it was 10.6. So how much is the difference? So how much HCl is needed for a first reaction? We need 10.6 cm3. When we did the second experiment, it was 14.9 here, and this is 36.1. So the difference between 36.1 minus 14.9, so difference is 21.2. So 21.2 cm3 of HCl is needed for a complete reaction. So if I ask which solution of HCl is more concentrated, so in experiment 1 or experiment 2, which one you think is more concentrated? Now the unknown solution is in a burette. The previous experiment, the unknown solution was there in a conical flask. But now the unknown solution in a burette. So for a complete reaction, we need a small quantity of HCl in experiment 1. Whereas for a complete reaction, we need a greater quantity of HCl for a complete reaction with 25 cm2 calcium hydroxide. So it means that solution M is more concentrated and solution N is less concentrated, because solution M contains more particles in a small space, so it can easily react and completely react with 25 cm3 with a small quantity. But where solution N, we required a greater volume, so it means solution N is having few particles in a unit space, or we can also say it is having a low concentration. So if unknown solution is in a burette, the one which we need a small quantity for a reaction is more concentrated. But if the unknown solution is in a conical flask, the one which required more amount from the burette is more concentrated. So the two experiments which we discussed now, the experiment 1, the previous experiment and this experiment, the previous experiment, the unknown substance was in a conical flask, but in this experiment, the unknown substance is in a burette. Now, what will be the color change? Because we are using phenolphthalein. Phenolphthalein is colorless in acidic, and in alkaline it is pink. So when we add drops of indicator here, so initial color will be pink because calcium hydroxide is alkali pink. When we add acid here, acid will react with an alkali, it will neutralize the acid, and now it will neutralize an alkali, and now we'll have an acidic solution or slightly acidic, so it will become colorless. So indicator will show a color change in this example from pink to colorless. So the table is there. We have to complete the reading. This was 10.6 and the difference is also 10.6. What about this one? In experiment 2, 15.1 and 14.9 and 36.1. So initial reading was 14.9 and 36.1. So the difference in the volume will come out as 21.2. What type of chemical reaction occur when hydrochloric acid react with calcium hydroxide when acid react with an alkali, that is called neutralization. The color in practical does not depend on amount of acid as it added. It depends on mainly the type of a medium. Indicator for universal indicator, it depends on amount of acid added. But for types of indicator, like example, we are having a phenolphthalein. So even a solution with a pH 8, pH 9, pH 10, if we are using a phenolphthalein, so phenolphthalein, it is colorless in acidic and it is pink in alkaline. So any alkali, it will be pink. So in the experiment, what happened? We have a conical flask, and that conical flask was filled with calcium hydroxide. And due to this calcium hydroxide, when we add drops of indicator, because calcium hydroxide is an alkali, so what will the color appearance? It will be pink. Now from the burette, we are adding HCl. So when we are adding an HCl, HCl is start to react with calcium hydroxide. Once the solution color will get lighter as the amount of calcium hydroxide decreases. But once all of the calcium hydroxide reacted, the solution instantly will show a color change because there is no more calcium hydroxide. And now it is, when we add another extra drop of HCl, the solution will be acidic, and in acidic, phenolphthalein is colorless. So it will change from pink to colorless. Intensity of the color depends on the concentration, but even if there's one molecule, like a small quantity, it will show a color change. In which experiment was a greater volume of hydrochloric acid used? So when we fill up the table, this was 10.6 was there, and this is 20 point or 21.2 was there in the second one. So which experiment greater volume? So that was experiment 2. So what will be the color here? As I mentioned, that because in a conical flask, you have calcium hydroxide initially. So when we add drops of indicator, initial color is pink. But when we add acid, hydrochloric acid, this pink color will change to colorless. The final, that it is colorless, initially it is pink. Because all of the alkali is used up, and then we'll have an acidic solution. So experiment 2, we are using a grater. Compare the volume. So when we compare the volume, you just have to write a ratio here. So when you take a simplest ratio, you divide by the smallest value. So ratio is 1:2. So how you write? You will say the experiment 2, the volume is twice, double, compared to experiment 1. Suggest an explanation for difference in the volume. So why there is a difference in the volume? Why we are using a different volume for the same reaction? Like in experiment 1, we use HCl from the burette, and we need only 10.6 cm3. Where in experiment 2, we use HCl and we need 21.2 cm3. So the reason for the difference in the volume with the same calcium hydroxide reaction, so the difference in the volume, because in experiment 1, HCl is more concentrated, so need a small quantity. So here suggest an explanation for a difference in volume. The concentration of solution M is different from N, and which is more concentrated? M is more concentrated. Or you can also mention M is having a twice concentration because we use a half volume. Then predict the volume of hydrochloric acid that would be needed to react completely if experiment 1 was repeated using 50 cm3 of calcium hydroxide. So how we can work out? For solution M and calcium hydroxide, when we were using 25 cm cube of calcium hydroxide, we need 10.6. But if we need a double, like if we want 50 cm cube, so we need X cross multiply, what we'll get 21.2 cm cube. So here 21.2 cm cube of solution M is needed. And the reason for that, because the volume is double for calcium hydroxide. So we need a twice as we use in the initial experiment. Suggest one change you would make to the apparatus to get more accurate. So how to get the more accurate? This answer is actually given in the question. As you can see, to add by using a measuring cylinder, they add calcium hydroxide. So which is more accurate? Pipette, we should use a pipette, or burette is acceptable. So we should use pipette to add calcium hydroxide instead of measuring cylinder, because pipette is more accurate. But disadvantage of the pipette, it takes time to transfer the solution. A student investigated the reaction between sodium thiosulfate and potassium iodide. It is a similar question what we did in the first page. Two experiments were carried out. A burette was filled to a 0.0 mark, and sodium thiosulfate solution is there in a burette. Then we use a solution A of potassium iodide, and then add sulfuric acid and potassium iodide, so it will form iodine molecule. And the solution thiosulfate solution was added to a flask. When the content of the flask get yellow or lighter, the starch is added and it will make it blue-black. And we continue to add until indicators show the starch, which is used as an indicator, become colorless. So here we at the similar experiment, we took sodium thiosulfate we fill it with burette with sodium thiosulfate. This is a formula for sodium thiosulfate, Na2S2O3, and in the mixture we have potassium iodide and potassium iodide, which will form iodine molecule. So when thiosulfate is reacting with iodine molecule, it will form an iodide ion. But this iodine molecule, the colors of iodine are important, and it is having different color. Like example, if we have iodine aqueous dilute, it will be pale, or you can say yellow. But if we have iodine aqueous and concentrated, it will be orange, or even brown is acceptable. If we have iodine in the presence of starch, it will be blue-black. The color of the iodine, it will be blue-black in the presence of starch. And if we have iodine in organic solvent, such as hexane, it will be pink. And iodine itself, iodine in a solid state, it is violet or purple. So these are the colors of iodine. Here, as you can see, initially, when we add sulfuric acid and potassium iodide, the flask was shaken in the mixture and produced a red solution, red, orange. This is one is because this iodine is produced in an aqueous solution, so it is brown, orange, red. These colors are all acceptable, depends on the concentration. But when we add thiosulfate from the burette, the amount of iodine concentration start to decrease. That's why when thiosulfate was added, the content of the flask were yellow. So why the content in the flask turned yellow? Because initially we were having more iodine, but as a result, the amount of iodine start to decrease, so it become yellow. And then we add starch as an indicator. So when we add starch, so iodine in the presence of starch is blue-black. That's why content of the flask, they did not specify it turn blue-black. But when starch is added, the same iodine will turn into blue-black. And once all of the iodine used up, so there will be no color of iodine and it will be a colorless solution. So we have to read the burette readings are there. As you can see, the scale, smaller value is top. So we'll read from top to bottom. Same thing here. We'll read from top to bottom, top to bottom. So what are the burette readings? Experiment 1, initially it was 0 and the final is how much? It is 39.2. So this was 39.2 and the difference is also 39.2. Then experiment 2, it was 8.1 and 28.7. 8.1 and 28.7, and this was the first one, which was 39.2. So when we take a difference, so 28.7 minus 8.1, which is 20.6. Yeah, so 20.6 is there, and the first one is 39.2. Now, suggest why the starch is used as an indicator. So why we use starch as an indicator for iodine reactions in like a reaction in which involve iodine, starch is always used as an indicator. Then in which experiment was the greatest volume of thiosulfate used? The burette was filled with thiosulfate. So which experiment you can see 39.2 is more than 20.6. So that the reason is in experiment 1. And what suggests a reason for the difference? No, we cannot write when the product is formed. You should always use the term it is used as an indicator. So we did 2 experiments. We filled the burette with a thiosulfate, and in a conical flask we were having potassium iodide and aqueous potassium iodide, which will form an iodine molecule. So from the first experiment, in the first experiment, we need 39.2, I guess it was 39.2. And the second one, we use 20.6. So which solution of potassium iodide is more concentrated, like solution A or solution B? So now the unknown solution is in a conical flask. So the one which required greater amount from the burette, because this is a known solution. We know thiosulfate, A and B means that is unknown. So here we need greater amount. Like example, in the beginning of experiment, the conical flask was filled with 20 cm cube. So we took 20 cm cube of solution A and we took 20 cm cube of solution B. But the amount of thiosulfate needed for first experiment, we need 39.2, and the second experiment, we only need 20.6. So it means experiment 1, the solution A is more concentrated because it needs more amount of thiosulfate for a complete reaction, whereas solution B is less concentrated because a smaller quantity of thiosulfate, it reacts completely. So compare the volume of thiosulfate for the 2 solutions. So it is approximately twice, or experiment 1 volume used is twice as compared to experiment 2. Normally it is twice. And which solution, which experiment that was suggest a difference? What is the reason for that? It means the solution A and B have different concentration. or solution A is more concentrated than B. A and B have different concentration, and A is more concentrated than B. Then predict the volume of thiosulfate for solution B needed to react with 10 cm cube of solution B. So example, for solution B, like we have a burette was filled with thiosulfate. This burette was filled with thiosulfate and we were using 20.6 cm cube, and the conical flask which was filled with 20 cm cube of solution B. Now they are saying if we use 10 cm cube of solution B, how much thiosulfate is needed? So how to work out this? You will simply use a ratio, like if thiosulfate is 20.6 and solution B which was 20. Now we are using 10, so this will be X. If this is half, this will also be half, or you can simply take a ratio, so it will be 10.3. So we need 10.3 cm cube of sodium thiosulfate for a complete reaction. Why it's of 2 marks? 1 mark you will show a ratio here, and the second mark you will predict the volume. Then explain one change that would be made to experimental method to obtain more accurate result without changing the apparatus. So only experimental method we have to change. We don't have to change the apparatus. So what would be the change in the experimental method? So here we are adding starch at the last moment. So what we should do, we should add a starch from the beginning so that it will be more accurate, because more prominent color change will be there. So because what we did, if you read this, answer is given in the question. Sodium thiosulfate solution was added, like first we take a conical flask, we fill this conical flask with potassium iodide and potassium iodide, which will form iodine molecule. And we add thiosulfate from the burette. Once this iodine the color get lighter, then we add starch. So we did not add indicator from the beginning, we just add indicator at the last moment. So what we should do, we should add indicator from the beginning. That's the procedure. That change will add starch from the beginning, so it will give a accurate volume when there is a color change.